sklearn Experimental Enable Iterative Imputer. Description: The Enable Iterative Imputer function in scikit-learn is an experimental feature that allows you to use the iterative imputer for handling missing values in datasets. It operates by iteratively imputing missing values using a specified estimator, e.g., a linear regression model. This approach is particularly useful for situations where the missing values are not randomly distributed but have a relationship with other features in the dataset. Inputs. X. This is the input feature matrix containing missing values. It should be a NumPy array or a pandas data frame. Estimator. This parameter defines the estimator to be used for imputing the missing values. You can choose from various estimators like linear regression, Bayesian ridge, or decision tree regressor. Outputs. Zimputed. This is the output feature matrix with the missing values imputed using the chosen estimator. Steps. Initialization. The iterative imputer initializes by assigning the input data to a temporary matrix. Iteration. The imputer then iteratively goes through each feature with missing values. For each feature, it selects the rows with complete data, i.e., no missing values in the current feature, and trains the chosen estimator using these rows. Imputation. The trained estimator is then used to predict the missing values in the current feature. Convergence. This process of iteration and imputation continues until a predefined convergence criterion is met, usually measured by the change in the imputed values between iterations. Metrics. Imputation accuracy measures how closely the imputed values match the true values, which are typically unavailable. Convergence rate reflects how quickly the imputation process converges to a stable solution. Visualization plots. Feature importance plot. This visualization shows the relative importance of each feature in the imputation process. Imputation history plot. This plot displays the evolution of imputed values across iterations, providing insights into the convergence behavior. Fine-tune parameters. Estimator. Choosing the right estimator, e.g., linear regression, Bayesian ridge, etc., is crucial for accurate imputation. Missing values defines the value used to represent missing data in the input data. Maxiter sets the maximum number of iterations the algorithm will perform. Toll specifies the tolerance level for convergence. Verbose controls the amount of information printed during the imputation process. Random state allows you to set a random seed for reproducibility. Uncertainty methods. Confidence intervals. The imputer can calculate confidence intervals for the imputed values, providing an estimate of the uncertainty associated with each imputed value. Imputation variance. By measuring the variance of imputed values, you can understand the variability of the imputation process. Challenges and fixes. Challenge 1. High computational cost. Imputing missing values iteratively can be computationally expensive, especially for large datasets. Sample use case that resulted in challenge 1. A dataset with millions of rows and numerous features with missing values. Fixes to challenge 1. Consider using a more efficient estimator, reducing the number of iterations, Maxiter, or parallelizing the computations. Challenge 2. Overfitting. If the estimator is too complex, it might overfit the data with complete values, leading to inaccurate imputation for missing values. Sample use case that resulted in challenge 2. Using a complex decision tree model for imputation. Fixes to challenge 2. Use a simpler estimator, e.g., linear regression, or regularize the chosen estimator to prevent overfitting. Challenge 3. Sensitivity to data distribution. The iterative imputer can be sensitive to the distribution of the data, particularly for nonlinear relationships. Sample use case that resulted in challenge 3, a dataset with a skewed distribution of features. Fixes to challenge 3: consider using a nonlinear estimator or transforming the data before imputation to handle nonlinear relationships. Challenge 4: convergence issues. The imputer may fail to converge within the maximum number of iterations. Sample use case that resulted in challenge 4: a dataset with complex relationships between features and a high percentage of missing values. Fixes to challenge 4: increase the maximum number of iterations max-iter, adjust the convergence tolerance tool, or explore different imputation strategies.